Welcome. I'm going to try and make today's just a little bit faster because last night's was the longest one we've had. Today it's lesson 2.2, so we're talking about tectonic plates, which are basically the most surface part of the lithosphere. So the top uppermost part of the crust, which is right above the mantle, which is what we discussed yesterday. Now when we talk about tectonic plates, we have 12 main ones that the crust is going to be composed of that are shifting and moving and grinding and causing all sorts of things on the planet. The three main types of interactions that we're going to have, so plate boundary interactions, are convergent, divergent, and transforming. When we look at them, there's three types of converging boundaries, which is what happens when we see two plates that are coming together. So converging, colliding, coming together, think of that as the C. The C is the big tip-off. Now between those three, we're going to have two oceanic plates that come together. We're going to have an oceanic and a continental plate that come together, or two continental plates that come together. And when that happens, what we're going to see is that when an oceanic and a continental plate come together, it's kind of what happens when you get to the beach. So the more dense plate is going to dip underneath, and the less dense plate is going to scoot above. What this is going to lead to is what we call a subduction zone, and this is how we get trenches and volcanoes. The other type is going to be an oceanic to an oceanic boundary. Again, you're going to see one dip underneath the other, which is also going to lead to those same trenches and volcanoes. And the last, when we have continent to continent, so to above ground, we're actually going to see the formation of mountains, so like Asheville, Boone, etc. So again, three types of convergent boundaries in which we have two plates that are coming together, moving together. The second type is divergent boundaries. There's two different types of these. When things diverge, they go apart. So divergent is plates coming apart. The first type is going to be oceanic and oceanic. So two underwater or oceanic plates are going to be coming together. And when that happens, you're going to see a similar situation. What's going to happen is you're going to get a ridge. So that dipping underwater is going to give you a mid-ocean ridge and allow for an opening to below ground. The last is if you have two continental plates, again, continent to continent plates diverging, what you're going to see is called a rift valley. So a valley is a sunken place. You're going to see a rift valley when two continental plates come apart. And finally, we have transforming plate boundaries. Transforming plate boundaries are when things slide back and forth as opposed to coming together. So they're going to strike at some point and slip. That's what we call it. Strike, slip, fault. When transforming boundaries happen, you see the most vibration and energy released, and it leads to some natural disasters that we're going to discuss later in this unit. An extremely important part of this lesson and this unit is understanding where all the energy comes from that allows the tectonic plates to shift around. And in our last lecture, we talked about how convection is one of those means. We're going to bring that back because convection is what's going to lead these 12 plates to moving around. That heat in the middle of the planet and the core is going to push up and melt rock in the mantle, creating magma that's going to rise up through the mantle. When it gets higher and away from the core, it's going to cool. And when it cools, one of two things can happen. It's either going to cause the push of our rock or our magma that's going to cause it to cycle down, or it's going to grab and pull it along with it. So you can push it or you can pull it, but either way we're seeing the cooling of magma, which gives you igneous rocks, and the push or pull of rock spreading away from the initial point. So hot magma is going up, cooling, and pushing or pulling down around. Then the cycle continues, so you're going to have hot magma, cold rock, melting again, creating this cycle that constantly has forces going up and around that allows the tectonic plates to move.